Hi, welcome to week 7. This is our second to last week of our summer prep series for Pre-AP Algebra 2. We have spent a lot of time on working with linear equations, linear functions, linear graphs, everything. So we're ready to kind of branch out a little bit. We did work with polynomials last week, which was a linear is included in something in the polynomial unit, but it is not just linear functions. So we're going to review today a concept that you learned in Algebra 1 called factoring. It will be used so much during Pre-AP Algebra 2 and then again in Pre-Calculus. And we do review some factoring in Pre-AP Algebra 2, but once we review it, we're pretty much done reviewing it, and you're expected to have it nailed down. So it's good to get some review over the summer. That'll make the review portion of Pre-AP Algebra 2 easier for you. And we do add some factoring methods and rules as we branch out into Algebra 2. Now, I'm not going to cover those today, but just know that in addition to what we reviewed today, you will learn some other factoring methods for different types of polynomials in Pre-AP Algebra 2. So I'm just going to hit the highlights of what the types of problems are that we're going to be asked to factor. So remember, factors are things that multiply together to get a term or a number or an expression. The greatest common factor you always look for first. And the greatest common factor would be what number or what variable or what number and variable do every term in the thing that you're being asked to factor. What do they have in common? What could I pull out of all of those and make it a more simplified thing to factor? So always look for a greatest common factor. We have a special case type of factoring for our quadratics called a difference of squares. We'll talk about that. When we're starting to factor trinomials, which would be our 3-term polynomials, and they're usually quadratic. The first piece is quadratic, the second piece is linear, and the last piece is a constant. We're going to be looking for sums and products of the numbers that are involved in that particular quadratic. Delta Math uses something called the X game. That is not a formal, if you type in X game on Google, you're not going to find this because that's just what Delta Math named it. But it's basically looking for sums and product combinations. We do use mental math when we solve quadratics, especially factor quadratics, when the leading coefficient is a 1. If the leading coefficient is not a 1, we use a method called slide and divide. You may have learned a different method from your 8th grade Algebra 1 teacher. Reverse box method, reverse FOIL. We'll talk about that. And then we're also going to solve quadratics only by factoring, because if we're practicing factoring, we might as well practice one of the ways to solve a quadratic, which is using factoring, okay? In order to solve by factoring, either you're going to be given a quadratic that's already factored, or it's going to be in standard form and you have to factor it in order to solve it. So the first thing we're going to review is greatest common factor. So if we look at the two, in this particular problem, we have 2 terms. We're looking for what number or variable, or a number and variable, or even multiple variables if there's more than one letter in here. What do these have in common? What is the biggest, greatest factor that they have in common? Now, if we look at these 2 terms, I think we can say 2 is the biggest number that they have in common. So when you pull out a greatest common factor, it comes in front, and these will be reduced by that amount, and that would be the number, that would be the expression left inside. And you look at that, what's left inside. It's possible you missed something. Is there anything left that I could take out of both of these? If the answer is no, then you know you have already taken out the greatest common factor. If the answer is yes, you can always take out more and bring it and join it out here with what's already there. So if you missed the greatest common factor the first time, just check your answer. If you think there's more you could have taken out, you can still do that. Now, if I look at this next one, first of all, I want to tell you that whatever the leading term is, whatever the highest powered term is, if it has a negative coefficient, that's a sign that you're going to take a negative greatest common factor out. We don't ever want to have negative leading coefficients. So I know I'm going to take a negative out of both of these terms. But is there a number that is 6 and a 27 have in common that I could take out? Is there a variable that we could take out? If we can take out a higher power than just a 1x, we can. And so that's what's going to happen here. I know I'm going to be taking out a negative. And a 3 and a 27, and please ignore my barking dog. I can take a negative 3 out of both of these terms. And then this is x to the fourth and x to the third. This is 4x's multiplied together. This is 3x's multiplied together. They each have at least 3 x's that I can take out of both. So I'm going to make negative 3x to the third be my greatest common factor. When I divide these, I'm left with a 2 and an x. And when I divide these, I'm left with a positive 9 and no x's left at all. Okay. Man, I had her outside and she was barking, so I brought her inside and now she's still barking. So frustrating. So sorry. Okay, we look at this last one. This has more than one variable. It has x's and it has y's. It doesn't have any coefficients to take out, so I'm not going to be putting a number in front of my greatest common factor. It's just going to be made up of variables. So if we look at it, this term has x to the third and this has an x. So they each have an x that can be taken out of them. Okay, so that's going to bump this down to an x squared, and this x is going to totally go away from that term. I have a y to the fourth and I have a y to the second. So this has 4 y's multiplied together. This has 2 y's multiplied together. They both have 2 y's that we can take out of each. That's whatever your lower exponent is, that's going to be the exponent that goes in your greatest common factor. Okay, so I can take an x and a y squared out of both of these. When I take an x and a y squared out of this term, I'm left with an x squared and a y squared. The minus sign is still there because we didn't change any signs. And I'm taking an x and a y squared out of this whole term. Well, that literally, this is a plus, by the way. I didn't realize that. That's a plus. You would see that more clearly on your screen. And then basically, I'm taking everything out of this second term. So you don't put a 0 there. You need it to be available to be brought back in. If you were to distribute this back in, you need a place for it to go to. So you just put a 1. Anytime you divide something by itself, it's 1, right? It's not 0. So make sure you hold the place with a 1, and we're done. Okay, now, if we have a situation where you are being asked to factor something, and it is simply 2 terms, and both of them are perfect squares, meaning you could take the square root of this, and there has to be a minus sign in between. This is called a difference of squares, not a sum. So I have to see a difference, a subtraction sign between these. But if both terms are completely perfect square roots, they have perfect square roots, then you can use, I'm going to write a little rule up here. And this can be anything. It doesn't have to be an x. It could be a number. It could be a variable other than x. It can be any variable with any power that is even. But this would be how you would factor it. They would look identical. You would take the square root of this. You would take the square root of this. You would put those square roots in each of the factors, one with a plus, one with a minus. Okay, so we're going to practice that. This is a difference of 2 things that I know the square root of. And so when I take the square root of 9x squared, I get 3x. So I'll put that at the front of both factors. When I take the square root of 64, I get 8. Put that at the back, one with a plus, one with a minus. Now, what I should have reminded you is look for a greatest common factor first. Okay, there isn't one here, but you should always look for it first. Otherwise, you could end up with 2 factors where you can see that there's something that could have been pulled out. 3x and 8 have nothing in common, so I know that's not the case here. But do look for a greatest common factor first. That is always true for any factoring problem I give you, even if I forget to remind you to do that. Okay, if we look at this, I can take the square root of x squared, and I can actually take the square root of y to the fourth. As long as it's an even power, cut it in half, that's the square root, that exponent. So I have 2 factors. Oh, by the way, this is what I would have written right here. Square root of x squared is x. The square root of y to the fourth is y squared. One with a plus, one with a minus. and you're done. All right. So difference of perfect squares is pretty easy. Even if you have higher powers, 8th powers, 12th powers, any even power is a perfect square. If there's a coefficient in front of it, you have to make sure that it is a perfect square too. Otherwise, you couldn't have done this. Okay, so now we're moving into reminding us how we factor quadratics that are trinomials. These are not trinomials, these are binomials, right? This is a quadratic and this is a constant. This is a quadratic and this is a quartic, but we still were able to treat it as a difference of squares. But most of the things we're going to be asked to factor are usually trinomials, 3 terms. And remember, in standard form, that looks like this. And there's an a, a b, and a c, a coefficient of x squared, a coefficient of x, and a constant. And so to get to the point where we're comfortable doing that effortlessly, we need to practice what it is, what the skill is that allows us to factor. And what it is we have to multiply a times c, and that is our product. That's the number that we are looking for factors of that product that add up to the middle term, which is the sum. So here they give us a product, and they tell you that this is a product because you see that times symbol there. And they also give us a sum, which is that indicated by that plus sign right there. What we're trying to do is figure out what are numbers that multiply together to get negative 18, but if I add them together, I get negative 3. So I know 18 can be multiplied by 6 times 3. If one of those was negative, and we also have 9 times 2, but I'm looking for a pair, if this is negative, I'm looking for a pair that is negative 3 apart from each other. If I put a negative in front of that 6, if I were to add those two together, I would get negative 3. So the numbers that I'm looking for are negative 6 and 3, and it doesn't matter which one you write where. It does matter that the negative goes with the 6, not the 3. No other combination of factors of 18, of negative 18, are going to give you that particular sum. So this is the right pair. Now if we look at negative 33, what are factors of negative 33 that add up to positive 8? So we could go with, well, really, the only thing we really have is 11 and 3. Now, if I want a positive sum, I need my negative to be with the smaller factor. Those two added together would be positive 8. So I need a positive 11 and I need a negative 3, and that's what's going to go in these boxes right here. And again, negative 3 can be here and 11 can be here. Okay. So that's just kind of reminding you of the sum and the product relationship as far as factoring. So now what I'm going to do is remind you of how to factor a very simple quadratic trinomial. I say simple because the leading coefficient, the a value, is 1. So what you're going to do is multiply that a value times that c value. 1 times positive 72. That is your product that you are looking for, and that would be 72. The sum that I'm looking for is a negative 17. So I'm trying to find factors of 72 that add up to a negative 17. For that to happen, both factors would have to be negative. That's the only way to get a positive product but a negative sum. So I think of 8 and 9. Those are the most commonly thought of factors of 72. If I made them both negative, they'd still be factors of 72, but if I added them together, I'm going to get that negative 17. So I'm going to write my factors. I'm going to split x squared into 2. I'm going to put a minus 9 with one and a minus 8 with the other, and it doesn't matter which one. And then as a habit, I always want you to divide the 9 and the 8. Whatever numbers you came up with over here, divide them by the a value. That seems silly when a is 1, because it's not going to change them, right? It's still going to be a minus 9, and it's still going to be a minus 8. And those are our answers. But when we get to harder trinomials, that is a step that I already want you to have in place, because that's a step that is very crucial for when the a value is not a 1, okay? And that I don't need to do a lot of these examples with you. I think you probably can do a lot of this in your head. You don't have to show all your work. As long as you know it's 1 times 72. Okay, 72, factors of 72 that add up to negative 17, negative 8, negative 9. Divide them both by 1. They're still negative 8 and negative 9, and put them in factors. Okay, And let's remind you, especially when the a value is not a 1, double check, make sure that the a value cannot factor out as a GCF. Okay, it can't here because a 3, a 22, and a 35 have nothing in common. But this is where we're going to practice that sum and product stuff that we did up here. So I have nothing that I can take out of all three of these. So I'm going to do A times C. 3 times 35 is 105. That is your product. Okay, you are looking for things that multiply together to get 105 that would add up to get 22. The sum is 22 that we're looking for. So I know this is divisible by 5 or maybe even 15, and that's exactly true. It's 5 and 21, and it's 15 and 7. Which pair adds up to 22? That would be this pair right here. So I'm going to split x squared into an x in each factor. I'm going to put a positive 15 with one and a positive 7 with the other, and I'm going to divide by the a value. Okay, if it divides nicely into that number, then that is your new factor. Okay, 15 divided by 3 is 5. If it does not, that means it is needed up at the front, in front of x, to be the coefficient of x, and that's going to look like 3x plus 7. I know that 3x squared was going to need a 3 somewhere in one of these two spots, and this shows us where it happens. The number that it goes in the factor that doesn't divide nicely by the a value, and that there is your a value right here. Again, you could have put plus 7 here and plus 15 here and done them divided by 3 here. As long as you end up with these two in any order, we're good. Let's look at the next one. The next one, this is a plus and this is a minus. So I'm going to do, look for a GCF. 5, 4, and 9, nothing. So I'm going to do 9 times 5, negative 9 times 5, sorry. That's our product. And I'm going to look for factors of negative 45 that add up to a positive 4. Okay, the sum is a positive 4. So I think of 9 and 5. Those are 4 apart from each other. I need to put a negative with one of them to get a negative 45 product, so I'll put it with the smaller number since I want a positive sum. And so I know that my factors will start with x. One of them is going to have a plus 9, one of them is going to have a minus 5, and then I have to divide by a, the a value of 5, to both of them. 9 does not divide nicely by 5, so that 5 needs to come in front of x in that particular factor. Here, 5 does divide nicely by 5, and so that factor reduces to x minus 1, and that is your pair of factors. All right, this is called slide and divide. We slid the a value over, but then we remembered to divide it at the end. That's why it's called slide and divide. All right, let's look at, these are cubic. And typically, at this point, you don't really have any methods for factoring cubics unless you can take out a GCF and make it a quadratic, okay? So let's just write a little note here. Try to find a GCF. Now, if you look at these, they need to be in standard form before you even attempt to take out a GCF. This one is. This is in descending order of power, so that's standard form. There are no numbers that this 1x to the third, this 1x squared, and this minus 42x have in common. Is there a variable that they all have in common? I see that they all have an x. And that is going to put us in a position now where we can factor what's left because it's now a quadratic. We can't forget about this x. So when we get our two parentheses worth of factors, don't forget that that x that you took out at the very beginning still needs to be present in your answer. Okay, it's important. So I'm going to go ahead and put the x at the front of my two parentheses that I know I'm going to have, and now I'm going to work on this down here at the bottom. So I have an a value of 1, a b value of 1, and a c value of negative 42. And we're going to go ahead and do our product. 1 times negative 42. The most popular factors I think of are 7 and 6. One of them needs to be negative. Since my sum is a positive, I need it to go with the smaller factor. So I'm going to have x plus 7 in one factor, and I'm going to have x minus 6 in another factor. Divide by the a value of 1, and nothing's going to change. So this will be x plus 7, and this will be x minus 6, and I have my answer. This next one is not in standard form yet. So before you do any type of factoring, let's rearrange the terms with the correct signs in front of them. and we are going to look for a GCF. Now, remember, if your leading term is negative, you're going to want to pull that negative sign out of that term, and that term, which just means it's going to change all of the signs of those terms. I also see that this is a cubic, so the only way I'm going to be able to do any further factoring is if I can pull an x out of all of these, and I can. So I'm going to pull out a negative and an x out of each of these three terms. And when I do that, that leaves me now with a positive leading coefficient. This turns to a negative 11x, and this turns to a positive 24. So I have a GCF that I cannot forget about, and I have a quadratic that I need to factor. So I'm going to bring that quadratic that's in the parentheses down here. And again, this is kind of mental math. You probably could have done this one in your head. When the leading coefficient is just a positive 1, it's pretty easy to do. So 1 times 24, looking for factors of 24 that add up to this sum of negative 11. So I think of negative 3 and negative 8, right? Those add up to be negative 11, but they multiply together to get positive 24. So my factors will have a minus 3 and a minus 8, and I'm going to again divide by that symbolic a value, which is just a 1 in this case, so it doesn't change them. And this becomes my factored answer. And then let's try one more. Now this one has some bigger numbers in front, so it's worth checking if that a value can be divided out of all of these, as well as an x, right? Because this is a cubic, so I can't factor it unless I can get it down to a quadratic. So I'm going to divide all of these by a GCF of 4x, and that's going to drop all of the x's down a power, and it's going to divide all of these by 4, and they are divisible by 4. So this would, if I take the 4 and an x out of this, that leaves me with an x squared. If I divide this by 4 and take an x out, I'm left with 14x. And if I divide this by 4 and take an x out, I'm left with minus 15. And so 4x definitely needs to go in the front of my two larger factors. And I'm going to bring this quadratic down and do the product and the sum work. So my product is negative 15. I'm looking for a sum that is positive 14. So these two added together would give me a positive 14. So I have an x plus 15 and an x minus 1. And I'm going to divide them both by 1 since that's my quadratic's leading coefficient, and they're not going to change. So that'll still be a positive 15, and that'll still be a minus 1. And I have factored everything they asked me to factor. Now, every once in a while, you'll get something where you may only be able to take out a GCF and nothing else. There are trinomials that are not factorable. Okay, so just keep that in mind. I don't know that they would give that to you already, but just in case they do, just know that that is a possibility always. Okay, and we're on our last page already. This is a shorter unit. So this last page is reviewing factoring as well as solving by factoring. So if we want to solve a quadratic equation, we have to have that equation equal to 0, which means everything needs to be moved to one side. Typically, we move it to the side where the x squared stays positive. Okay, so if I look at this problem right here, it is not ready to be solved yet because it's not set equal to 0. So if I look at where the x squared is, if it is already positive, then that is the side where I want to bring everything else. The minus 210 is already on that side. I just need to move this 9x away from this side, and I would do that with subtraction. And it would pop up in the middle of the x squared and the constant. So we would end up looking for an answer that has this particular standard form order. And I think you can see that that is present here. So that is the correct answer. I can see my A, my B, and my C. I would be ready to factor now at that point. Okay, so just make sure you remember to solve a quadratic, especially by factoring, and several other methods that you've already learned, and we'll talk about those next week when we talk about quadratics some more, has to be set equal to 0. Now, this particular problem is already set equal to 0. So if you already have a factored equation, everything that has x's on this side has been grouped into factors, then what you're going to do is set every piece, and it could include a GCF if that had a variable in it. This one does not. I want to solve the equation for all values of x. So that means I need to solve this for x, and I need to solve this for x. Anything that has an x in it needs to be solved. if it's already factored. The -2, basically, if I were to divide that away, it just gets absorbed into this 0. So I don't have to worry about a GCF that's just a number. But these two guys, I do. So I'm going to set x plus 2 equal to 0 and solve. And I'm going to set x squared minus 36 equal to 0 and solve. Well, this one is linear, so all I have to do is move the x over. So -2 is one of my solutions. You'll put a comma, and that's going to open another box. You need as many boxes as there are solutions. Now this, I can factor this further. This is a difference of squares. The square root of x squared is x, and the square root of 36 is 6, and there's a minus in between them. So I can use that factoring rule that we practiced on one of the last pages, and this gives me 2 more factors to set equal to 0 and solve for x. And so I end up getting a -6 for this solution, and I get a +6 for this solution. Now you could write those as 2 separate factors, or you could use this plus or minus sign. If you click that and then put a 6 in, it's going to recognize that you say that 6 and -6 are both solutions. So you don't have to use that. You could just type in -2, comma, -6, comma, +6, and it'll still recognize that it's correct. This plus or minus sign is just a kind of a shortcut. All right, now, what if they're not already factored? That would be the culmination of our lesson today, is can you get this in a factorable form so that you can factor and then solve, meaning that everything is already to one side and you have 0 on the other side. So it reminds you of that. It can't be done until the equation is equal to 0. So I recommend moving everything to the side where the x squared will stay positive, and you have a 0 on the right side. So when I add 2x and I take away 5 from this side, I end up, these cancel each other out. This gives me a -9. It was already a -4 and I took away 5 more. This is what I have to solve. So I need to factor this. That is a difference of squares, difference of perfect squares. I can take the square root of this and the square root of this, and it's a difference. So the square root of x and the square root of 9 would make those two factors x plus 3 and x minus 3. I'm going to set those equal to 0, and that's going to give me these two solutions, -3 and +3. If it's quadratic, more than likely you're going to have 2 solutions, especially in this unit. All right, let's look at this one. This one has the x squared on this side where it's already positive, so that means I'm going to move everything to that side that is not already there by taking away and adding whatever it takes to get them to cancel out from the side that they're on. So I end up with 3x squared. These combine to be a 5x, and these combine to be a +2, and it is now solvable. So I'm going to factor this side. So this is not a trinomial where there's anything I can take out as a greatest common factor. There's just not. Always look for that first. So I need to just do my slide and divide method. Luckily, everything's positive, so I'm not going to have to worry about any negatives. So I'm going to multiply a times c, 3 times 2, which is 6. And I'm looking for factors of 6 that add up to 5. And I think we can all agree that those would be the right 2 choices. So my factors will have a +2 and a +3. But I need to divide by my a value to get the correct factors. Remember, when you slide the 3 over, you've got to remember to divide it back out. 2 does not divide by 3, so that is going to be the factor where the 3 gets brought to the front. 3 does divide by 3, so that factor is going to reduce to just 1. Now here's the final step. We still have to solve for x. This is a solving, not just a factoring. So I'm going to take 3x plus 2 and set it equal to 0, which is going to end up giving me a fraction, which is totally fine. Lots of solutions are fractions. -2/3. And then x plus 1, when I set that equal to 0, I get -1. And so my solutions are -2/3 and -1. And then our final challenge problem for solving by factoring, this is a cubic. So let's rearrange it in descending order. It's already all to one side. Now let's remember that if your leading term is negative, you want to be sure to pull that negative out, if not more. Now this is cubic, so I need to at least get an x out, if not a number as well. These are all divisible by 3. They're also all divisible by x. And I'm going to take that negative out as well. So I'm going to take out a GCF, that is a negative to get rid of the leading coefficient's negative sign. I can take a 3 out of all these numbers and an x out of all these numbers. So I'm going to pull a 3x out of a negative 3x out of all of these guys. You don't have to show this step where it shows division happening, but it does visually kind of help some people divide. So if I divide negative 3x squared by negative 3x, I'll end up with just an x squared. That's what I was hoping for. Positive 3x squared divided by negative 3x is going to leave me with negative x, negative 1x. And then these two divided would leave me with negative 30. And it still equals to 0. So I'm now going to work with this using slide and divide, or just mental math, since it's a coefficient of 1 now. 1 times negative 30. I'm looking for factors of negative 30 that will give me a sum that's a negative 1. So I think of the two factors that are 1 apart, and I'll stick the bigger one with the negative. So this ends up being x minus 6 and x plus 5. And dividing by 1 isn't going to change those at all. So if we look at what we need to solve for, we don't just have two factors with x, we also have a GCF that has an x in it. I can ignore a GCF when I'm solving that doesn't have an x in it, but if it has an x in it, it has to be set equal to 0. We need 3 solutions here. This is a cubic. Cubics usually need 3 solutions because the leading coefficient with the power of 3 kind of tells you that. So I'm just going to do the work. I have 0 as a solution, I have 6 as a solution, and I have negative 5 as a solution. And those would be, and you can type those in any order. Every time you type a comma, it'll open up another box for you to write another solution. And that is it. So next week, we'll do our last unit, which is on all things quadratic. And we kind of have a little preview of that here. Take care.